Can you hear me? Okay. Shalom, everyone. My name is Dror Tamir. I'm the co-founder and CEO of Hargol Foodtech, and we are the world's first commercial grasshopper farm. We all know that global demand for protein is expected to double over the coming decades, and we also know that existing protein sources are reaching their limitations. Animal-based protein is harmful to the environment, while plant-based protein requires heavy processing, is not as healthy as we want it to be. So we can all understand that the demand for high-quality alternative protein will skyrocket over the coming years. However, these new sources have their own set of limitations. For example, algae suffer from very distinct taste and flavor, and cultured meat is years away from becoming commercially viable. Insects have been attracting a lot of attention, in particular, these guys, crickets, but they too have their own set of problems. First, crickets do not fit intensive farming. Crickets do not fit intensive farming. Crickets are individuals and they tend to die at high densities. Second, they suffer from a very distinct taste and flavor, making them a challenging ingredient for the food and beverage industry to work with. So the real solution is grasshoppers with a whopping 70% protein content, all essential amino acids, very high on omega-3, omega-6, iron, zinc, and folic acid, very low on saturated fat and cholesterol. They are an amazing product. They're also neutral in taste and flavor, making them the perfect ingredient for the food and beverage industry to work with. And most importantly, grasshoppers' tendency to swarm, making them best suited for intensive farming. At Hargol Foodtech, we invent new methods and technologies to grow grasshoppers on commercial scale. We developed a climate-controlled environment that enables us to grow grasshoppers year-round, when others can only do it seasonally. We reduced the incubation period of the eggs from 40 weeks to 2 weeks, meaning we increased the number of life cycles per year from 1 to 10. And the cages we developed for vertical farming enable us to grow 10 times more biomass per square foot while maintaining well-ventilated and sanitized environment for the grasshoppers. With Hargol's innovation, grasshopper farming is efficient and scalable. Let me tell you about the market, because the market opportunity is huge. 5 years ago, this is the US insect protein market. 5 years ago, it was zero. Last year, it already reached $100 million, and it is expected to reach $1 billion in 5 years' time. The reason it is growing only 40% annually is because of the supply, not because of the demand. Hargol already have orders from customers in the US, in Europe. Actually, this presentation, I sent it 2 weeks ago. It's not updated anymore. The producer here, the organizers wanted a presentation ahead, so I'll have to fix a few things. We already have orders from Asia and Australia from the past 2 weeks. And the best compliment we got in this project came from our competitors, the cricket farmers in North America, that made inquiries about adopting our technology to grow their own grasshoppers. And grasshoppers are also the perfect food for pets. Let me introduce you to the team that cracked the grasshopper code. Hanan Aviv is our CTO. And Hanan, for over 30 years, has been growing, breeding, and eating a wide variety of insects. And you can see the result because he's the only guy with hair on his head on our team. Ben Friedman, that specializes in operations efficiency and regulation, and myself with experience in business development, financing, and marketing. Let me show you a little bit about the traction from the last 12 months we had. You can see the names of the leading food and beverage companies in the world and in Israel. And again, 2 weeks ago, this slide was updated, but the number is now not $5 million, it's over $7 million already, with a large deal we have from Finland. And we also have a few more collaborations beyond that slide. As you can see, we are also winning international innovation competitions. So again, a few weeks ago, we won Tnuva. Tnuva is the largest food producer in Israel. We won their innovation competition, and we are starting to develop a meat replacement product with them. So, this is Hargol Foodtech, and my name is Dror Tamir. And if someone is daring to take a kosher bite from the future, because grasshoppers are kosher, I have some samples for you. Thank you.
Hello. My name is Noam Alkan. The presentation. Okay. My name is Dr. Noam Alkan from Vulcani Center, Department of Post-Harvest Science, and I was challenged to talk also in 5 minutes, but after all it will be very hard to follow. I will talk about red fruit that have high anthocyanin. They are more attractive and healthier, but we will try to show you that they are more resistant to cold and pathogens. So anthocyanin are compounds that are responsible for the red color of mango. They are polyphenol, antioxidant. They are synthesized from a pathway that's called phenylpropanoid with the flavonoids. And these antioxidant and antifungal compounds are healthy and promoting our health. A few years ago, we checked close to 100 different cultivars of mango fruit. We inoculate them with a fungal pathogen, and you can see that some of them are very resistant and some of them are very susceptible to fungal pathogens. And interestingly, we saw that the red cultivar to purple cultivar are more resistant than the yellow to green cultivars. We also store those cultivars in suboptimal temperature of 6, so also a lot of variation in their susceptibility to cold. Also here we found that the red cultivars are more resistant than the green cultivars to cold. But there is a lot of problem with different cultivars because they vary a lot between different cultivars, and we want to focus on one cultivar, even better on one tree. So mango trees that are exposed to sunlight, we found that they are accumulating flavonoids and anthocyanin, and they become red, and the fruit that develop within the canopy, they remain green. Indeed, the red mango that was exposed to sunlight had more antioxidant, and then they had less oxidation of lipids when they were stored at suboptimal temperature of 5. Indeed, when we store those fruit at suboptimal temperature of 5, the red mango fruit developed less symptoms of black spots and pitting and was more resistant to chilling. But not only that, when we store those fruit at optimal temperature of 12 and 20 degrees, the red fruit had less stem and rod decay and side decay and was more resistant, but this is natural infection. And now when we infected the red mango fruits from the red side and the green side, and the green mango fruit from the green and red side, we saw that the red mango fruit developed less decay than the green fruit, and also at the green side of the red mango fruit, we had less decay. So the resistance of the red mango fruit is on both sides, not only on the red side. In order to see if the anthocyanin and flavonoids and all these polyphenols are responsible for the resistance to fungi, we extracted those polyphenols, and indeed they inhibit the fungal growth more than the green extract and inhibit the conidia germination. The next stage was to induce the red color in green cultivars and make them more attractive and more resistant. And when we pruned the trees in order to expose the fruit to light, the fruit developed a high red color in comparison to the control, and after shelf life, they were much more attractive and nicer. We also applied several natural compounds as pro-hydrojasmol that called blush and ABA, and fruit from the inside of the tree and outside of the tree when we applied those materials, was much more redder, attractive, healthier for us. So overall, we saw that different natural compounds like PDJ and ABA and even sunlight elevate the induction of anthocyanin and red color in mango fruit, and also, of course, in other fruit as well that develop anthocyanin. Those anthocyanin are antifungal compounds and antioxidant, which are healthy for us, and this reduce chilling in mango fruit and reduce anthracnose. And thank you.
Thank you, Noam. That shows that red is the new green. This is a great introduction to our session. We will not deal in this session with food losses, which this mango treatment is means to reduce food losses. We will talk more about reducing food waste. And when we gather all the information